Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, it may be too late for that, but I'll try. The ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy, so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland show that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please. My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean, between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust and, in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, it's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. A bunch of super brainy scientists with even brainier computers. The first scenario, a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored super ocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film, each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too. Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widen into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's 4th largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, The same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
Put on your woolen hats, find the warmest mittens, and go buy the thickest blankets. The next ice age might be just around the corner. And the trigger is much more shocking than anyone might have expected. What's even worse? We have no control over our bitterly cold future. Earth's climate has been on a wild ride for millions of years. It's been warming up, freezing over into ice ages, then heating up again to the more normal temperatures we know today. These cycles, called quaternary ice ages, are part of a much longer pattern of global freezing and thawing. For a long time, scientists thought Earth's orbit around the Sun had something to do with triggering ice ages, but figuring out exactly how was tricky. Well, new research has finally connected the dots. It shows how tiny changes in Earth's tilt, wobble, and orbit mess with the growth and melting of huge ice sheets. This is a pretty big deal because it helps scientists understand not just what happened in the past, but also what might happen to our climate in the future. Even small shifts in how Earth moves through space can have huge effects over thousands of years. These changes control how much sunlight different parts of the planet get, which affects how ice sheets grow and shrink. Earth doesn't orbit the Sun in a perfect circle. It actually follows a slightly oval-shaped path. This phenomenon is called orbital eccentricity. Since the Sun isn't sitting right in the center of this oval, Earth's distance from it changes throughout the year. Plus, the oval itself slowly shifts position in space over time, which is called orbital precession. On top of that, Earth's tilt, aka obliquity, also changes slightly as our planet moves around the Sun. Scientists have known for a while that these orbital quirks impact our planet's climate, causing cycles of warming and cooling. As different parts of Earth's orbit shift, they change how sunlight is distributed across the planet, influencing seasons and ice ages. These Milankovitch cycles happen roughly every 20,000, 40,000, 100,000, and even 400,000 years. The difficult part is to figure out how each of these orbital changes affects climate shifts. Earth's climate is a complicated system, with tons of factors influencing it at the same time. Modeling all these processes is no easy task. It needs huge computing power and a deep understanding of each factor's role in shaping our planet's past and future climate. There are two cycles that are super close to each other in timing. Precession, which happens every 21,000 years, and the second harmonic of obliquity that happens at 20,500 years. But even though they're so close, no one has been able to directly connect either of these cycles to the end of an ice age. On top of that, for the past 800,000 years, ice ages have ended every 100,000 years, and scientists still haven't figured out what causes this pattern. To get to the bottom of it, researchers turned to the deep sea. They studied changes in oxygen isotope ratios found in the tiny, fossilized shells of marine creatures. These tiny creatures live in the ocean, and their exoskeletons preserve clues about past climate, specifically changes in ice sheets. This allowed the researchers to track the beginning and end of ice ages over the past 800,000 years. By comparing the changes in the ice sheets with Earth's orbital changes, they found an incredible pattern. The key moments when Earth moved between ice ages and warmer periods were perfectly lined up with specific relationships between precession and obliquity. It turns out that the end of an ice age, called deglaciation, is closely linked to the way precession and obliquity align. But it's obliquity alone that seems to trigger the start of an ice age. This discovery is the key to understanding the 100,000-year cycle of ice ages. The researchers say it was always there, just waiting to be noticed. Before the discovery, people thought the timing of ice ages was more random. But this new study shows there's a clear, predictable pattern. This means we might actually be able to predict when ice ages will happen in the future. Right now, Earth's tilt is slowly decreasing, and in about 11,000 years, it'll hit its lowest point. Based on the team's calculation, the next ice age is expected to begin before then. At the same time, according to the latest reports, humans have already started pushing Earth's climate off its natural path by releasing greenhouse gases. Another thing scientists are warning about is a massive shift that's happening in the Atlantic Ocean, and it could drastically change the world's climate. The Atlantic Meridional Overturning Circulation is a system of ocean currents that moves warm and cold water around the planet. And right now, it is showing signs of weakening. What will happen if it collapses? Freezing temperatures in Europe, extreme weather across the world, shifting monsoons, and even an Amazon rainforest drying up. And the scariest part? Some researchers say there's a 95% chance this could happen before the end of the century. Think of the AMOC like a giant conveyor belt in the ocean. Warm, salty water from the tropics flows north towards Europe and North America. When it reaches colder areas, it cools down, becomes heavier, and sinks to the bottom of the ocean. This deep, cold water then moves southward, while fresh, warm water from the equator keeps flowing north to replace it. This system helps regulate global temperatures, keeps Europe's winters mild, and prevents the US East Coast from flooding. It also controls monsoon patterns that bring seasonal rain to parts of Africa, South America, and Asia. Without it, the world's climate would look completely different. Right now, melting ice from Greenland and Antarctica, along with increased rainfall and river runoff, is dumping too much fresh water into the North Atlantic. Since fresh water is lighter than seawater, it disrupts the sinking process that keeps the AMOC moving. If too much fresh water builds up, it will mess up the entire system. And once it collapses, there will be no reversing it, even if the climate later cools down. Scientists have seen two big warning signs. First of all, the warming of the ocean off the US East Coast, which suggests the AMOC is already slowing down. Plus, there's a cold blob of water south of Greenland. It might be a sign of the weakening of the ocean current, and that's exactly what happens before the system fails. What would happen if the AMOC fully shut down? Europe would enter an ice age. The AMOC plays an important role in keeping Europe's winters relatively mild by bringing warm water north. If this process stopped, Europe would be plunged into deep winter. London's climate would drop by 18 degrees Fahrenheit, making it feel like northern Canada. Stockholm could get up to 54 degrees Fahrenheit colder. turning it into Siberia-like conditions. And snow and ice would cover much of northern Europe year-round. Next, monsoons would shift, leading to severe droughts. The AMOC helps regulate tropical rainfall, especially in Africa, South America, and Asia. If it collapsed, West Africa's monsoons would shift or disappear, leading to devastating droughts and a massive food crisis. The Amazon rainforest could dry up, transforming into a savanna or grassland. In India and Southeast Asia, monsoon rains would disappear, and millions of people rely on them for agriculture. The U.S. East Coast could see catastrophic flooding. With the AMOC weakening, water is already piling up along the U.S. East Coast, triggering higher sea levels and stronger hurricanes. If the system shut down, sea levels would rise by up to 3.2 feet, which would make the coastal cities more vulnerable to flooding. Finally, hurricanes and extreme storms could become even more powerful because of warmer waters along the coast. Now, how close are we to disaster? For thousands of years, the AMOC has remained stable, but recent studies suggest it's weaker now than at any point in the past 1,600 years. Ocean temperatures are hitting record highs, and many researchers believe we are dangerously close to the tipping point. A study published in Nature claims that if greenhouse gas emissions continue at their current pace, there's a 95% chance that the AMOC will collapse before 2100.
The Baltic Sea anomaly. In 2011, a diving team came down to the bottom of the northern part of the Baltic Sea. They went on a treasure hunt, but what they came upon was a pretty weird object. When they took photos and showed them to others, many believed it was a sunken spaceship of another civilization. Other people thought that some natural causes formed the object, but the metals inside the structure definitely couldn't have been formed naturally. Now, some scientists even believe it was something that appeared way back in the Ice Age. Maybe it was even a meteorite that ended up trapped under ice back then. A maelstrom is a whirlpool, some sort of a powerful rotational current that forms when two currents collide and create a circular vortex. Even fearless Vikings were afraid of maelstroms because those were forces so powerful that they could sink large ships. These whirlpools remain dangerous even today, but luckily, not for big modern ships that are large enough to withstand the power of maelstroms. But a cruise ship that gets into a maelstrom usually faces massive waves that can rock even big vessels from side to side pretty intensely. A maelstrom can be so strong, it can turn into some sort of an underwater black hole. Yep, black holes are not only present in the cold expanse of space, you can find them here on our home planet too, swirling in the oceans. They're similar to those in space, since they're compacted so tightly that nothing they trap can escape. Underwater black holes often span up to 93 miles in diameter. And if you got into one of those, you probably wouldn't even know it. These black holes act like vortices, but because of their size, even professionals can hardly see their boundaries. Here's something relaxing. Next time you go to the beach, pay attention, and maybe you'll see an optical phenomenon called the green flash. You can see it shortly after sunset or right before sunrise. It occurs when the sun is almost completely below the horizon, while its rim, the upper one, is still visible. For just a second or two, that upper edge of the sun will appear green. It's because you're looking at the sun through thicker parts of the atmosphere as it's moving down in the sky. As it's dipping below the horizon, light refracts, or bends, in the atmosphere and gets dispersed. Wait for a clear day with no clouds or haze on the horizon to see this phenomenon better. You've been looking forward to a nice swim, only to realize that the water in the ocean is red? Better avoid going in. Florida is known for its red tides. It occurs when the concentration of specific microscopic algae is higher than normal. thousands of species of algae in marine and fresh waters are mostly harmless to animals and humans. They even help us, since they're an important source of oxygen. But some, like the algae that makes the ocean red, can be extremely dangerous for marine animals, like sea turtles, fish, and seabirds. This kind can grow out of control and produce neurotoxins harmful to humans, especially those who have some respiratory issues. Such people should avoid red tide areas, especially when winds are strong enough to push the algae toward the shore. Volcanoes can spew poisonous gas, ash, and red-hot lava. Those are the most obvious dangers most of us already know about. But submarine volcanoes can be very tricky in their own way. Sometimes, when they're located in shallow waters, they reveal their presence by blasting debris of rock and steam high above the surface. Since submarine volcanoes are surrounded by an unlimited supply of water, they can behave differently from those on land. When they erupt, seawater gets into active submarine vents. Lava can be spreading across a shallow sea floor, or sometimes even flowing into the sea from land volcanoes. When in water, it may cool down so quickly that it shatters into rubble and sand. So, there are large amounts of volcanic debris left there. You know those popular black sand beaches in Hawaii? That's how they formed. Hot lava and powerful eruptions certainly don't sound safe, but submarine volcanoes in deeper waters are equally dangerous, even though they're not necessarily erupting. They produce pockets of bubbles. These bubbles reduce the density of the surrounding waters, which can even sink ships. The worst thing is that when you look at the surface of the ocean, you can't understand something's wrong. But at the same time, tiny bubbles are there, causing ships to lose buoyancy, and with very little warning. A cross sea is a rare phenomenon, beautiful to observe, but also very dangerous. It's when you see square waves, which are more common in shallow parts of the ocean. That's something you can often see in France or on certain beaches of Tel Aviv, but it can also happen in many coastal areas across the world. A cross sea occurs when two wave patterns travel at oblique angles. They form this checkerboard-like pattern. It mostly happens when two swells meet, or when a swell pushes waves in one direction, while a strong wind pushes them in another. These square waves can be dangerous for swimmers and boaters. The waves produced by strong ocean currents can be pretty unpredictable and tall, sometimes up to almost 10 feet. This phenomenon is sometimes called white walls. These waves can be so powerful that they can turn over even big boats. If you fill a clear glass with some ocean water and take a closer look, you'll see it's full of very small particles. Seawater contains dissolved salts, fats, algae, proteins, detergents, and other bits of artificial and organic matter. If you shake that glass, you'll see tiny bubbles forming on its surface. That's how sea foam forms when waves and winds agitate the ocean. When you see thick sea foam, algal blooms might have caused it. When big blooms of algae fall apart in the sea, large amounts of that matter move in the direction of dry land. Most kinds of sea foam aren't dangerous to humans, but when blooms of algae fall apart, it can have a negative impact on both the environment and people. For example, when sea foam bubbles pop, the toxins they contain get released into the air, and they can irritate your eyes or cause some other health issues. You can see a tidal bore in the areas where a river empties into a sea or an ocean. It's a powerful tide that goes against the current and pushes up the river. A tidal bore falls into a category of something called the surge, which is a sudden change in depth. A tidal bore is a positive surge, which means it pushes up a river, making it much deeper. A negative surge is when the river suddenly becomes very shallow. You won't see tidal bores everywhere. The river must be fairly shallow with a narrow outlet to the sea. The place where the sea and the river meet must be flat and wide. Also, the area between low and high tide must be at least 20 feet across. Of course, there are some exceptions, like the Amazon River, the world's largest one. The mouth of the Amazon is not narrow, but the river experiences tidal bores. That's because its mouth is shallow and has many sandbars and low-lying islands. The tidal bore is so strong there that the river doesn't even have a delta. Its sediment goes directly into the Atlantic Ocean, where fast-moving currents take it away. A tidal bore is often unpredictable and can be extremely rough. In many cases, it changes the color of the river from greenish or blue to brown. It can damage vegetation or even tear trees out of the ground. So, recreation sports like kayaking and river surfing can be hazardous in these areas. Even if you just want to take a look at a tidal bore, be careful. Tidal waves can sweep over lookout points and drag whatever or whoever is there into the churning river.
Wow, a giant roiling mountain of a thundercloud is moving towards you. It's completely black and goes in stark contrast with the bright blue sky right above and behind you. You see a blinding flash and, in a few seconds, a deafening whip-like crack of thunder. And then the rain starts gushing down from the heavens. The wind rises. You see treetops bending low towards the ground some miles away and getting closer by the second. You freeze in place, realizing you can't escape anyway. But when the rain almost reaches you, its movement suddenly stops. Just a few feet before you, there's a veritable flood, but right where you stand, it's dry and even sunny. And after a short while, the angry thundercloud spills its last drops and disperses. Seeing the edge of rain is a rare thing, but not impossible. The rain has to be really powerful so that the wind couldn't diverge the drops from their vertical path. If the rain is light, you'll only be able to see its edges from far away. It looks like a shimmering gray haze going all the way from the sky to the ground. Now the rain's passed, but the wind is still blowing and rising ever stronger. You see leaves flying around in a circular pattern and realize a tornado is about to start. You run as fast and far away as you can, climb some hill, and only then stop and turn around. No tornado yet, but the cloud that's hanging up there looks menacing. Another flash and a whip crack. The lightning has struck a lone tree near where you just stood. It caught on fire, and there's a column of flames rising to the sky. Still no rain, and the pillar becomes taller and taller. You've heard of such a thing, but never seen it. A fire tornado. This phenomenon occurs when the wind is caught in a circle close to the ground because of the difference in air pressure. Such mini tornadoes are usually easy to notice. Small rubble, dust, sand, and leaves rise into the air and start flying in rapid circles. But then, if there's a source of fire nearby, the funnel can catch it and blow it stronger, like bellows. The flames go round and round, reaching even higher, and eventually creating a swirling, blazing tower. Luckily, fire tornadoes are short-lived and don't normally cause much damage. If that wasn't enough, you feel some rumbling from below. No, it's not your tummy. It's low and ominous. You look up and see strange lights hanging above the ground. They look like shimmering balls of light hovering high up in the sky. Your throat goes dry and you gulp. That's what they call the earthquake lights. This phenomenon is poorly understood, but witnesses say they've seen it in different shapes and sizes. It could be in the form of light balls, sheet lightning, streamers, and steady glow in the sky. Soon after, a strong earthquake follows. Scientists can't explain why those lights appear, and they don't always do either. Some believe there's a reaction of underground gases released into the atmosphere. Sure enough, an earthquake begins. But lucky you, it's not as strong as you expected. The ground is shaking, but you even manage to keep your balance. It stops as abruptly as it began, and you walk home. Later that night, you look out the window and see something incredible, a rainbow. But it's dark already and the moon is shining in the clear night skies. Ah, wait, that's exactly what it is, a moonbow. Also called a lunar rainbow. This event occurs extremely rarely. It's similar to a regular rainbow in everything except that it appears on a clear, moony night after a rain shower. Thankful for such a spectacle, you go to sleep. Next morning, you look out the window again, and suddenly, the sun is all but blocked, and it seems to be night again. You hear distant rustling and some kind of cawing. Puzzled, you look up and you can't believe your eyes. There are thousands upon thousands of birds in the sky, so many that they block all sunlight. This is called sort sol, or black sun in Danish. Very fitting. Normally it only happens in Denmark, hence the name, where numerous migratory starlings take to the air at the same time to look for a place to stay for the winter. There are so many of them that they literally make the sky go black for a few moments. So, what are they doing where you are? Well, that's a good question. Okay, you're now magically transported to Antarctica. We're in an imaginary universe, so anything can happen. Of course, you're properly dressed in warm and cozy clothes. You look around in bewilderment and realize you've been transported to the slopes of Mount Erebus, one of many volcanoes of the icy continent. Right now, it's slowly cooking, gas seeping out from its top and fissures on the sides. What draws your attention, though, are snowy pillars all around you. These are known as snow chimneys. They form thanks to the boiling magma underneath. It occasionally spews up hot gas toward the surface, but the chill outside stops the hot stuff. As a result, fumaroles are formed. The hot gas freezes over as soon as it hits the air, creating peculiar ice statues. They let out thin strands of smoke almost all the time and grow as the gas tries to escape from the nether. Well, that's enough of the freezing cold and volcanoes. Time to go to milder climes. Whoosh! And you're in Los Angeles. Look up! Almost right above you, there's a beautiful rainbow cascade of clouds. These are called a fire rainbow or circumhorizontal arc. Again, it's a rare thing, but here in LA, it's much more likely to occur than, say, in London. Fire rainbows only appear when the conditions are right. It's close to the equator, the weather is clear, there are feather-like clouds in the sky, and the sun is higher than 58 degrees above the horizon. Such clouds are made of ice crystals, and when the sun's rays hit them, the particles refract the light and create a rainbow. Wow! Oops, jumping to another place again. This time you find yourself in Indonesia, overlooking another volcano. Its name is Kawah Ijen, and it's the world's most beautiful fire mountain. You see it slowly erupting, but the lava lazily flowing out of its maw isn't red, it's blue. Inside the Kawah Ijen, there's much more sulfuric gas than in any other volcano. When the mountain erupts, the gas goes out under extreme pressure. As soon as it hits the open air, it triggers a chemical reaction which turns the fire blue. Ever seen a gas stove burning? Here, the principle is basically the same. Whoosh! And you're in the bitter cold of the Arctic. Oh, come on! Still, as soon as you see the frozen ocean, you forget all about the cold. There are frost flowers blooming on the surface. Marvelous crystals of fragile ice seem to grow from the thin sheet of the frozen sea. Such flowers only occur near the shore or on lakes when the difference in temperatures above and on the waterline is drastic. At least 27 degrees is required. When the warmer ice on the surface meets the colder air above it, water vapor appears and freezes rapidly. This creates brittle but beautiful structures on the surface, which can even grow taller with time. Your next destination is not much warmer, still the Arctic Circle, but Siberia now. Strangely, at first you see nothing around but the endless green valley and a low hill nearby. But then, you notice that the ground is trembling. An earthquake again? No, you see the hill shaking as if it were about to burst, and then it actually bursts. An ear-splitting boom takes your hearing away for a few seconds, and you see huge boulders flying in every direction like meteorites. When you return your gaze to the ground, there's no hill before you. Instead, there's a huge, wide, and deep crater. You've become witness to a permafrost explosion, a new and poorly explored phenomenon. The main theory is that low mounds sometimes form in the frozen plains of Siberia, pushed upwards by expanding natural gas hidden underneath. At some point, this gas can explode, leading to a powerful burst, and the mound pops like a water bubble, a massive, extremely dangerous pop. Look out, there's a stray boulder flying right at you. Woof! You've been transported right on time, and hey, you're back home. The thunderstorm is over and whoa, what are those clouds? They look extremely sinister. Well, don't worry, they're called mammatus clouds, and they're perfectly safe. They tend to appear before or after a severe storm or a hurricane. Normally, clouds form thanks to warmer air going up, but these ones form because of cooler air sinking down. It creates pockets made of ice and water, which droop down in distinct lobes. They don't hold on for too long though, 15 minutes at the most, and then they're gone. You look at the sight, shake your head, and go home. That's a bit too much for one day.
If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain, and that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern US. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern US from the drier western US, is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the US, and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the US population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters. But areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern US and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
Now, if you were to check out the Sahara from space right now, instead of a barren wasteland, you'd spot a surprising sight. Dry land sprinkled with some lakes and rivers in Morocco and Algeria. all thanks to some heavy rains in early September 2024. These aren't oases. This is just the Sahara going back to the factory settings. Believe it or not, eons ago, one of the biggest deserts on Earth was actually a lush paradise full of greenery. Let's first see how the Sahara turned into a desert. During the last ice age, Earth was much colder, and big ice sheets covered a lot of the land. At that time, the Sahara Desert was significantly bigger than it is today, and on our planet there were fewer tropical forests. And the cooler temperatures changed how rain was distributed in the tropics. Now normally, warm air rises in the tropics, which helps create rain. Since it was colder during the Ice Age, this system got, messed up, and less rain fell in some areas. This caused more dry and desert-like conditions in places that are usually wetter. There was also a lot of dust blowing around in the Sahara Desert, which scientists found in old ocean sediments. But about 12,500 years ago, something surprising happened. The dust levels went way down. This meant that the Sahara got a lot wetter, which is a sign that the climate suddenly warmed up for a while before cooling down again. After 12,500 years ago, the Sahara became a much greener place, like a savanna, because a weather pattern called the Intertropical Convergence Zone, a mouthful indeed, moved north during summer. This wet period was at its best around 4,000 years ago, when temperatures were a bit warmer than today. At that time, more rain fell in the Ethiopian highlands, which made the Nile River carry more sediment. However, there was another big change called a Heinrich event, which caused the Intertropical Convergence Zone to move back south. This led to the Sahara and Arabian regions drying out quickly. Because of this, the Nile River had much less flooding between 2700 and 2100 BCE. Long story short, too late for that. The Sahara has gone through wet and dry cycles due to changes in the climate and weather patterns over thousands of years. Up until recently, we've known about the Sahara in its dry era. But in September 2024, an unusual cyclone rolled through. It hit Morocco, Algeria, Tunisia, and Libya, and filled those dry lakes and rivers. The satellite images from NASA of before and after the rains are stunning. It's like the Sahara has had a makeover. Some areas in North Africa received up to 8 inches of rain. For comparison, Seattle gets about 40 inches per year, only 5 times what the Sahara received. I say only for one simple reason. Seattle has a reputation for being quite rainy, while the Sahara does not. The tricky part is those 8 inches. Essentially, the entire yearly quota for this area fell in a matter of moments. So, in a way, it might have felt rainier in the Sahara than in Seattle. The mountains funnel the water into ephemeral lakes in northern Algeria, which recently expanded to over 70 square miles and reached depths of more than 7 feet. That's enough water to sustain it for a year. So what exactly are these ephemeral lakes? Well, they're basins that fill up for a short time each year, but might stay dry for several years if the rain doesn't cooperate. Sometimes water flows into them from a small surrounding area, or it can just be good old-fashioned rain. Now, a big question arises. How come these lakes exist in the first place? Well, generally they form because there's excess water trapped on the surface. But the soil in the Sahara is incredibly dry. Shouldn't it act like a sponge? It must be thirsting for moisture. Well, think about how eagerly your potted plant drinks up water when you return home from a vacation. However, no matter how parched it is, dry soil can only absorb a limited amount of water, which is often quite small. And just like your potted plant, it doesn't necessarily drink it all. You might simply be overwatering. Or, if you check the saucer below, you could find a mini flood. Another significant factor preventing the soil from absorbing water is the lack of vegetation. Under normal conditions, trees, shrubs, and various plants help retain moisture. In the desert, however, it's nearly impossible. There may be a few palm trees, but that's about it. This also explains the formation of those temporary lakes. Precipitation that isn't held by plants accumulates in low-lying valleys and depressions, creating these fleeting bodies of water. These lakes may only last for a limited time, but that doesn't mean they shouldn't have names. For instance, the beautiful lake adorned with swaying palms that you see is called Lake Yasmina, located in the oasis town of Merzoga. In certain areas of the desert, where the dunes rise, it may appear as though you're looking at a mirage, but it's not. The sand dunes are partially covered by water. Remember how I mentioned 8 inches? Well, that's not entirely accurate for some regions. In fact, there are places where the flooding is so extensive that the palms are submerged up to their crowns. Now, the last time we saw a downpour this intensive was 30 to 50 years ago. But this rain is more than welcome. After 6 consecutive years of drought, Morocco really needed it. Lakes that had been dry for decades, like Lake Ariki, are finally getting some much-needed water. A recent analysis revealed that out of the hundreds of storms that have hit the region since 2000, only 6 brought enough rain to start filling up this lake. And of those, only 2 resulted in a lake level higher than what we saw in September 2024. So while this torrential rain seems like a blessing, the big question is, will it last? The answer is yes. When humid air from near the equator meets the hot, dry air from the north, the Sahara Desert tends to get more rain. Scientists say this collision zone is shifting further north as the planet warms, and it warms, so it's likely to keep moving that way over the next couple of decades. So I seem a bit overly optimistic about this, and the truth is, the news isn't entirely positive. The reality is that no one was truly prepared for a flood situation like this. Moreover, remember that this isn't some Southeast Asian country where people are accustomed to dealing with water. This is the bone-dry Sahara. That said, I think you know what I'm getting at. Tragically, at least 18 people lost their lives to the intense rains in southern Morocco. The authorities are gearing up for even more heavy rain in the region. But if that's the case, could it mean the Sahara is facing extinction? And what would that even mean for us? It might sound a bit strange, but our planet actually relies on deserts, and the Sahara is no different. At first glance, it may seem like a barren wasteland, and it's nothing to write home about. But deserts play a crucial role in our ecosystem. They act as major carbon storage sites and are considered net carbon sinks, with the Sahara alone holding an estimated 1 trillion metric tons of carbon. In the fight against climate change, these existing deserts are like a buffer, helping to keep the temperatures within acceptable levels. Yeah, deserts are scorching hot, but they act as the world's air conditioning. Plus, desert sands are an unexpected source of nutrients for lush areas like tropical rainforests. Believe it or not, scientists have found that the sand particles from the Sahara have a hand in nurturing the Amazon rainforest. These particles travel across the Atlantic Ocean, riding the winds all the way to South America, where they enrich the soil in the Amazon basin. Without the Sahara, experts believe the Amazon rainforest could face serious collapse.
About a year back, something wild happened on Mars. Its magnetic shield and air around it expanded to about 3 times the usual size. Earth has experienced this ballooning before too. In 1999, it caused our magnetosphere to expand up to 100 times its usual size. And scientists are saying that Earth might experience it again soon, but on an even larger scale. The consequences of that could be catastrophic. Let's see why it happens and what might happen to us if that repeats. NASA's MAVEN orbiter has been orbiting Mars since 2014. It's the only spacecraft we have that keeps track of both the Sun and Mars. In 2022, on December 26th, it witnessed a fascinating show on the red planet. Mars's atmosphere and magnetic shield suddenly stretched out by thousands of miles. According to scientists, it's a unique, unbelievably dramatic event, and MAVEN was there to catch it all. Scientists tried to uncover this mystery. Digging into the event, they discovered something incredible. It turns out this air show was linked to the solar winds. Solar wind is the stream of particles coming from the sun. It's a constant flow of protons and electrons from our star's outer atmosphere. Moving super fast, up to 500 miles per second, these charged particles travel through the solar system in a plasma state. Mars, like all other planets in our solar system, is always dealing with solar wind. Think of it like a breeze from the sun. This wind pushes on Mars's magnetic shield, called magnetosphere, and is part of why Mars loses some of its atmosphere into space. Researchers found out that the weird expansion on Mars happened because there was a rare void in it. Faster solar wind caught up with slower solar wind, making them squeeze together. This created a gap in part of Mars's atmosphere because some solar wind was missing. This unusual situation caused Mars's magnetosphere to expand so rapidly. The Sun goes through a cycle about every 11 years. It jumps from low activity, or solar minimum, to high activity, or solar maximum. Then it jumps back. We noticed this way back in the 18th century, and we're currently on the 25th cycle. It's all because of the Sun's magnetic field. During solar minimum, the magnetic field is strong and organized, but over time it weakens. Suddenly, solar activity jumps up. This creates solar winds, the Sun spewing jets of particles on the planets, including our Earth. In 1999, the solar wind nearly disappeared for 3 days. It will probably repeat again now. This time around, scientists believe it might hit us sooner and harder than expected. The Sun becomes quite lively, emitting fiery plasma, developing large dark spots and releasing powerful radiation. And unfortunately, the upcoming solar maximum kind of caught us off guard. The storm was predicted for 2025, so scientists aren't very prepared. The number of sunspots observed has been way higher than anticipated. The Sun hit an 8-year sunspot peak in 2022, and then showed more than double the expected sunspots in 2023. It's not just them. Many solar flares have also been on the rise. In March, the geomagnetic storm lit up the skies with vibrant auroras across 30 U.S. states. It was the strongest storm in over 6 years. Many rare solar events have become more common recently. For example, a gigantic plasma waterfall, a polar vortex swirling around the Sun's North Pole for hours, and a 3-day solar tornado towering over 14 Earths. Because of all that, Earth faces some risks. Solar storms could hit our planet. It can mess with communications, damage power systems, and cause blackouts, and even pose threats to living beings. They can ionize Earth's atmosphere. This would mess with radio signals and GPS systems. Major disasters like earthquakes or tsunamis combined with such blackouts could lead to catastrophic outcomes. Additionally, strong solar storms may generate electrical currents that can damage infrastructure, including power grids and rail lines. Airplane passengers might experience higher radiation levels during solar storms. It's hard to tell what that would mean for their health. However, astronauts on spacecraft such as the International Space Station could face more significant risks. Future space missions will have to take solar cycles into account. We're not the only creatures in danger. These storms can disrupt the migration patterns of animals like gray whales, sea turtles, and birds. All these poor animals rely on Earth's magnetic field to understand what's going on. And as a cherry on top, there's a risk of satellite collisions. Commercial space companies are focused on launching satellites quickly rather than safely. Because of that, they often overlook the impact of space weather. During solar storms, the ionized upper atmosphere increases drag on Earth-orbiting satellites. If something goes wrong, satellites can be forced out of orbit and collide with us. The scariest solar storm that has ever happened to us was the Carrington event. In 1859, Earth experienced the most intense geomagnetic storm ever recorded. The sky lit up with vibrant auroras. They were visible from the North and South Poles to places like Cuba and Japan. The display was so bright in the United States that gold miners woke up thinking it was morning. It was caused by a massive solar flare. The auroras were breathtaking, but the impact was more than visual. It disrupted telegraph systems across Europe and North America. Telegraph pylons threw sparks. Operators got electric shocks. and conversations were conducted using the auroral current instead of batteries. Similar storms occurred at least 3 times throughout history, with the same awful consequences. Scientists estimate the cost of such an event today could range from $600 billion to $2.6 trillion in the US alone. Researchers continue to study historical events and ice core data to understand and prepare for the potential impacts of future solar storms. The sun's behavior is very unpredictable, but this just shows that we need to study it in greater depth. The chance that this new coming storm will be the same as a superstorm like the Carrington event is low. Besides, if we spend this time preparing, it might go unnoticed. Preparation usually involves adjusting satellite trajectories, grounding planes, and identifying vulnerable infrastructure. Meanwhile, we keep exploring Mars. Its atmosphere is different from ours. Our atmosphere has breathable air, mostly consisting of nitrogen, oxygen, and a lot of other gases. Meanwhile, Mars has incredibly high CO2 levels. If on Earth carbon dioxide doesn't even reach 1%, on Mars, it makes up about 90% of its atmosphere. Also, Earth's atmosphere is over 100 times denser than the one on Mars. Even though Mars is about half the size of Earth, its atmosphere is like a feather compared to our air. A long time ago, Mars could have been kind of Earth-like. We know that it definitely had water, and perhaps there were even some plants. If we added water on Mars now, plants could have grown up there. A long time ago, Mars was experiencing some serious volcanism, suggesting it had a thick atmosphere and maybe even a giant ocean. We're not sure what happened to them, but there are some theories. For example, Mars has a magnetic field, but it's very weak, so solar winds could have stripped away its atmosphere. In the end, it became the chilly, dusty red planet we know today. NASA's Perseverance rover celebrated its 1,000th day on the red planet with some amazing discoveries. The rover cruised through an ancient Martian river and lake system. It gathered 23 precious samples along the way. All of these samples will help us to unlock Mars's history and geological mysteries. Extreme events and conditions are horrifying, but great in a way that they help us to learn more about our solar system. Luckily, MAVEN was designed to be sturdy and prepared even for intense solar storms. So now we can find out more about Mars when it's stripped of its protectiveness.
Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot, even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo Pangea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. The Arctic is disappearing. In just a few years, the North Pole could see its first ice-free summer in the last 125,000 years. But a bold new experiment might turn back the clock. Scientists are refreezing the Arctic. If they succeed, they could save the North Pole. But if they fail, they could trigger unforeseen disasters. So, which way would things go? Well, here's some backstory. Deep in the Arctic, temperatures drop so low that metal cracks and winds scream across the ice. In winter, it's minus 30 degrees Fahrenheit on average. But despite the seemingly extreme cold, it's actually melting, warming 2 to 3 times faster than the rest of the planet. Now, ice is like Earth's natural mirror. It reflects sunlight back into space, keeping the planet cool. When it melts, it exposes the dark ocean underneath. The ocean absorbs sunlight instead of reflecting it, and it spreads all across the planet. This warms the planet even faster, melting even more ice. It's a vicious cycle, and if it continues, we'll reach a point where the ice won't come back. That thick, ancient ice that has covered the North Pole for thousands of years is already 95% gone. It's been disappearing since the 1980s. The ice that remains there now is thin and fragile, and when it disappears, it will trigger a dangerous chain reaction. Meanwhile, a group of researchers from a UK startup called Real Ice is out there trying to slow down or even reverse the melting of the Arctic. The project takes place in a tiny frozen village in Canada called Cambridge Bay. Real Ice wants to break the vicious cycle, and here's their plan. First, they drill through the existing ice and place an underwater pump beneath it. Then they pump seawater onto the ice surface, where it quickly freezes into an extra thick layer. Finally, they remove snow from the ice, which usually acts like a blanket, preventing further freezing. After that, ice keeps growing, stronger, thicker, and harder to melt. It's a simple idea inspired by nature itself. Ice naturally forms this way in some Arctic regions, but now scientists want to do it on a massive scale. So far, it appears to be working. Between January and May 2024, they covered around 44,000 square feet of ice, and it became 20 inches thicker on average. And in November 2024, they started a new round of tests. In the first 10 days of the trial, the ice was already 4 inches thicker. Now they'll return in May 2025 to check out how things are going. They think it's going to get between around 16 to 31 inches of it during the Arctic winter. It's a small start, admittedly, but if they can prove it works, their plan is to expand across an area more than twice the size of California, about 386,000 square miles of ice. And they're not stopping there. The big idea is to send in 500,000 underwater drones, powered by clean energy, to automate the entire process. These drones would drill holes, pump water, and refreeze the ice without human intervention. But not everyone is convinced. Some scientists think this whole idea is a disaster waiting to happen. First, they point out that saltier ice, the one from seawater pumped onto it, melts faster in the summer. So if this new ice melts too quickly, we could end up making the situation worse. Some of them also think this is a dangerous distraction from the core problem, like treating the symptoms instead of the root causes. Besides, making a small patch of ice thicker is one thing, but doing this across the entire Arctic? That's another challenge entirely. Another thing they're worried about is the ecosystem. The Arctic is one of the most fragile ecosystems on Earth. Changing ice thickness could affect marine life, disrupt algae growth, and impact the food chain in ways we don't fully understand. There's also the question of money. Real Ice estimates that refreezing the entire Arctic will cost about $5 to $6 billion per year. Who's paying for this? Right now, they're self-funded with some investors backing them. But eventually, they hope that countries, global funds, and even corporations will finance the project. Real Ice argues that doing nothing could be far worse. If we don't act, we could lose the Arctic within our lifetime. That could at least help to buy more time to fix the planet. Desperate times call for desperate measures. Now, the idea of saving the Arctic ice isn't new. Over the years, scientists have suggested some pretty wild plans to stop the melting. In 2017, there was the initial wind-powered pump plan. Physicist Stephen Desch proposed installing about 10 million wind-powered pumps in the Arctic. These pumps would pull seawater up onto the ice, kind of like real ice. It would freeze in the cold winter months, creating a thicker ice layer. The biggest problem is that someone would have to run this entire show. And what happens if something goes wrong? In 2018, there was the Glass Beads Plan, which was supposed to start in 2020s. A team called the Arctic Ice Project suggested covering the Arctic with tiny reflective glass beads. Yep, glass balls. The idea was basically to replace the ice's mirror effect. The beads would bounce sunlight away, keeping the ice colder for longer. The plan is being tested by a group of scientists working with the Arctic Ice Project. They say the glass balls are made of a material that's safe for animals. They even claim birds use similar materials to help them digest food. The glass used in these microspheres is the same material used in lab equipment and light bulbs. Sounds safe, right? Well, not so fast. There's also the environmental risk. These glass balls are tiny, and they could easily get into the ocean, impacting everything from fish to plankton. We still need more research to understand how this material breaks down in the ocean and whether it could affect marine life. But where things get really crazy is when we start talking about scaling this up. To cover just a tiny fraction of the Arctic, they would need millions of tons of these tiny microspheres, and that's just for starters. And they'd have to be working 24/7 through freezing temperatures and snowstorms. The scientists believe this could help keep the ice thick enough to survive summer and even slow the melting. But can it really work? Then there's also the Bright Ice Initiative, founded by the same folks behind the Arctic Ice Project. Instead of focusing on the Arctic Ocean, they want to use the same glass microspheres to restore glaciers. They've even tried this out on a glacier in Iceland, but experts are still skeptical. They say it could just speed up melting instead of reversing it. Now, another idea was cloud seeding with water particles. This would involve spraying ocean water into the sky itself. This would form clouds, and they'd reflect more sunlight. So, as you can see, some of these plans were too expensive, too complicated, or just straight up wild. The Real Ice's plan borrows ideas from earlier projects, but is much cheaper and more practical. Most importantly, it's working. But all this Arctic disaster is already affecting people. In the village of Newtok, Alaska, the land is disappearing. Each year, about 70 feet of the riverbank erodes, taking homes and history with it. That's all because of the erosion and the thawing permafrost. Now, these people had to move to a safer place called Murtavik, just 9 miles away. But it's a long and challenging journey. The relocation has taken years of planning, with Newtok residents already starting the shift in 2019. The new village offers better health and safety, but it's still a work in progress. Things like the school and grocery store remain in the old village, which makes things harder. Water and sewage systems are being set up, and for now, most residents are using a honey bucket system. But at least they have a chance to rebuild. It's still unclear whether these geoengineering ideas are a lifeline or a disaster. For now, we can just keep an eye on them. A mega drought might hit Australia soon, and this isn't just about a couple of dry seasons. We're talking about 20 years of little or no rain. While Australia could be facing the longest and most devastating drought since official records began, the rest of the world might struggle to buy bread, flour, or cereals. Energy prices are likely to spike globally, and neighboring countries like New Zealand, Indonesia, and Malaysia must be prepared to receive Australians directly affected by the lack of water. To truly understand how severe this situation could become, we should first examine past disasters. First off, Australia is no stranger to droughts, and this phenomenon can happen across their entire territory. From 2017 to 2019, the southeast part of the country went through what they call the tinderbox drought. This was a severe bone-dry event where the cooler months saw only about half the usual rainfall. Parts of Australia became so dry that wildfires were a constant threat. Crops failed, and water was scarce. This drought was also thought to have contributed to the Black Summer fire disaster. By the end of 2019, bushfires were raging across the country on a scale never seen before, with people describing them as rivers of lava flowing down from treetops. The losses were staggering. The tourist industry alone took a hit of $2.8 billion, and over 7,000 jobs disappeared as a result of this difficult period. The tinderbox drought was a big reminder of what Australia might face in the future. That's why it's so important to understand what happened in the past to get a full picture of a possible 20-year mega drought. But there is one problem. Even though droughts are relatively common in Australia, the rainfall data available until today isn't enough for researchers to predict the future, and our records only go back to around 1900. So experts decided to study tree rings to uncover missing environmental data. If you look at a tree stump, you'll notice concentric rings on its surface. As trees grow, they form new rings, and the thickness of these rings depends on how much water they get. During a megadrought, the rings appear thinner because the trees don't have much water. Unfortunately, these natural records usually only go back a few hundred years, and it only tells us about specific local conditions, not the situation across all of Australia. So, experts turn to computer models to simulate how Earth's climate changed from the year 850 to 2000. This approach helped them to paint a picture of when megadroughts might have occurred in Australia and how to predict what might happen in the future. But what they were really interested in was whether the human factor might be making this scenario worse over the years and if we are somehow intensifying these dry periods. So, are we to blame for these megadroughts? The short answer is, we're not sure yet. On one hand, dry periods in Australia do seem to last longer than they did before factories and machines became common. On the other hand, they don't seem to be getting more intense or happening more often than before industrial times. This means a drought lasting 20 years might not be directly linked to human activities. Actually, this kind of phenomenon is just a normal part of how rainfall changes in Australia over time. This is backed up by evidence from ice cores, which suggests that a 39-year drought hit eastern Australia around 800 years ago. What makes it all so fascinating is that there isn't just one cause for this phenomenon. I mean, there is no single mechanism that explains all cases of megadroughts. It happens because the right combination of ocean and atmospheric conditions come together, and you end up with a drought. And just by random chance, you might have periods where there are 100-year-long droughts. Despite what many people think, megadroughts are not geographically isolated. They have occurred on every continent except Antarctica over the past 2,000 years, and are often linked to natural events. For instance, megadroughts in North America and Southwest South America were driven by El Niño, where the Pacific Ocean near the equator gets warmer than usual, disturbing normal weather patterns. They are not rare events either. In fact, the U.S. Southwest has been experiencing a mega-drought since 2000. It's being considered the driest period in 1,200 years for the region. Major reservoirs like Lake Mead and Lake Powell are at low levels. Heat waves are hitting cities like Phoenix and Las Vegas harder than ever. And wildfires are happening more frequently as the land gets drier. Now, let's think about the future. Even though we have a very recent and concrete example from the U.S., research can't exactly predict how a 20-year megadrought would play out in Australia. Usually, such events show up mainly as reduced rainfall and snowfall. But in most areas, the increase in drought risk will be caused by a warmer, more arid atmosphere. So the ground will probably look parched and cracked, rivers and lakes will likely shrink, and the sky will be relentlessly clear and blue, with barely a cloud in sight. Farmers might struggle to grow crops, making grocery prices rise worldwide. Things like bread, flour, and cereals may become scarcer, as Australia supplies about 13% of global wheat exports. Coal mines might be affected, as they depend on water for extraction, washing, and processing. That might drive up power costs for industries around the world, which could be passed on to consumers, impacting global growth and inflation. As cities might face water shortages, Australians will likely find new ways to conserve every drop or maybe move to New Zealand or Southeast Asia. Now, you're probably thinking, when is this big event going to happen? Honestly, it's really hard to predict exactly. Megadroughts can happen every 150 to 1,000 years, but experts think Australia should be ready for one to happen in the next 10 years or so. And this possibly should be taken seriously. This phenomenon has been known to contribute to the collapse of entire civilizations. Take the Akkadians of Mesopotamia, who built the world's first empire more than 4,000 years ago. Studies of moisture at the ruins of Akkadian cities suggest that they experienced a massive drought lasting 300 years, and this may have led to their collapse. A similar thing happened to the Assyrian Empire, which existed over 2,700 years ago, in what is now northern Iraq. For years, it was a real mystery why they left their capital of Nineveh and never returned. But recent studies of a stalagmite in the Cunaba cave revealed that the rise and fall of the empire coincided with a wet period followed by a 125-year-long mega-drought. Because they were very dependent on seasonal rain for agriculture, this dry period made their life much harder. Even though experts now believe they probably left because of the dryness, the question of where they went is still a mystery. So, yep, mega-droughts may have played a role in the collapse of great civilizations in the past. But on the positive side, we've come a long way since then, and recent climate technologies can help us prepare for events like this. Now that we know a 20-year mega-drought is very much possible and might happen soon, Australia has some time to get ready for it. Developing strong water management plans to mitigate the severe impacts of a mega-drought is more than necessary, and it's also important to create community support networks to provide emotional and financial support to people, particularly farmers, who are more affected directly by this event. If initiatives like these emerge in the coming years, those 20 years of drought could be less intense than most people might expect.
These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ansilonema alaskana and the Ansilonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile-deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it.